Hello and welcome to the Srijan Wednesday webinars. If you're joining us for the first time, this is a community initiative by Srijan Technologies, where you can tune into a variety of sessions ranging across the topics of technology, entrepreneurship, and community building. In today's session, we are going to take a look at some key advantages and limitations of automated testing and how to avoid the traps of poorly written tests. And finally, we dive into creating powerful test automation systems that work for your project. And to take us through all of this, we are joined by Nitin Mukhija, VP Testing at PayU Payments. Before we begin, I would request all participants to please type in any questions that you have about the presentation, and we will take them up in the last 15 minutes of the session. Also, please don't forget to take the conversation live on Twitter using our hashtag SrijanWW. You can share your thoughts by tagging us in your tweets using our handle at the @Srijan and Nitin's handle, which would be up on your screens right about now. So without wasting any more time, let's dive in. Nitin, over to you.
Hello, good evening, everyone. I hope you're able to hear me loud and clear. I'm very excited to be here today and presenting this webinar. First of all, I would like to share that this is the first experience for me to present this presentation through this medium of webinar. I've been doing this presentation earlier on in various conferences and various meetups. And the way I have done this presentation earlier is through a lot of face-to-face interaction and engagement with the audience. I love a lot by standing in between the audience, starting conversation with them, engaging them, asking them a lot of questions, doing a lot of discussions with them. But this is a very different medium for me to do this via webinar, where I guess it will be mostly a one-way conversation where I'll be speaking a lot and then I'll be getting your questions through some chats. So let's see how this goes. But I'm really excited to be here today presenting this webinar. So the topic I have for today's webinar is, as Nilanjana said, first of all, and also I would like to thank Srijan Technologies for giving me this opportunity to be here today to talk to the QA community, the testing enthusiast people who want to know more about automation. So thanks, Srijan. Thanks, Nilanjana, for giving me this opportunity. So the topic here today is key ingredients of a powerful test automation system. First of all, before we start that, I would like to basically, this is again, as I said, I have done this more as a face-to-face conference or meetup. So I usually ask my audience, okay, why do you want to automate? Now, since it's not possible to get your answer, so I'll just move to the next slide. Okay, fine. I'm assuming that, okay, most of you would know that, okay, fine. Manual is slow. We want faster feedback for our continuous integration testing. We don't want a manual tester to do the same things over and over again, because they will actually lose focus if they do the same thing again and again. We want to keep them motivated, excited, give them newer work. So hence we automate the boring regression task. And also when we have like a lot of legacy products, it's easier to have the good automation in place so that we can anytime do refactor of that, upgrade of that without worrying about breaking the legacy scenarios. Plus, automation also serves as a platform to offer documentation. Usually there are complaints that, okay, nobody's putting effort in documenting the new changes. But again, if you have automation, you are actually documenting the whatever is you are building in the product. Additionally, it offers you the higher test coverage with multiple data combination. And then I'm sure, like, because I didn't have much space in this slide, there are tons of other reasons for doing automation. But I would like to again ask back the audience. It's not possible here in this webinar, but the question which I have in mind is that you know why to automate, but are you ready to automate? there is some trap. People think that, okay, now they know, okay, why they should automate. So they simply start automating. Is this sufficient motivation to start automation? Or to say it other way, just by knowing that, okay, why you should automate, should you simply start automating? The answer is no. There is a trap. Now, what is the trap? Let's see that. Okay, let's take an example first. Before I mention some facts, let's take an example. Let's say you are testing a calculator function, and in a calculator, you do the operation 2 plus 2 equal to. Now, when you do press 2, then you press plus, then you press 2 again, and then you press equal to. The obvious answer, okay, the people will say, okay, just verify that the 4 appears. And you automate that. You automate, okay, fine, press 2 plus plus, press 2 again, press equal to, and the answer, verify that the answer is 4. Now, just compare this thing that you had done the automation of this thing with a situation where you are testing it manually, and then there is a bug in the system where 4 appears, but then after appearing for a few seconds, it disappears. Or 4 appears after, let's say, 5 seconds. It takes a long time to get the result. Now, if you are testing it manually, a human mind will actually recognize this problem that, oh, 4 appeared but then disappeared immediately, or 4 took long time to appear. That means there's some performance issue. Okay, so manual tester will notice these problems. But what will automation do? Your automation script will just wait for 4 to appear, and as soon as 4 will appear, it will say, okay, test case pass. If the 4 disappears after being displayed on the calculator screen for a few seconds, it disappears. The automation test case will still pass, saying that, okay, yes, 4 appeared. But the bug was that, okay, it appears and then it disappears. So the point I want to put across here is that it's not sufficient to know that, okay, why you should automate. You should also understand, okay, what all you should automate. Don't fall into trap of automating everything. You can't replace the manual testing. A human mind, it's God gift. It's given by God. It has rich intellectual capabilities. Scientists and researchers are still trying to simulate human mind through artificial neural networks. In AI, a lot of research is going on, but then they're not able to replace a human brain. So same just point I want to put across is that, because a lot of people come to me, freshers from the college, they come to me and saying that, okay, we want to do automation. I ask them why. They say because we love coding. Now, is that the motivation? You should do automation that because we love coding? The automation is supposed to solve your problems, and plus you should know what all to automate and what all not to automate. Automation has to be used very carefully. You can't automate everything. So that's what I wanted to put across in this slide, that never equate your manual testing with automation testing. Manual testing involves human capabilities, which is far more powerful. A human mind will instantly notice hundreds of problems which we don't even think we are looking at. And a human mind can tell difference between a false alarms, but automation will get confused. And obviously you cannot do 100% automation because you can't codify human knowledge. Let's take another example. Whatever system you test, for example, I'm part of PayU. Even though I'm working with PayU since last 5 years, I don't know the entire PayU system. The system is so big, and plus so many people have worked on it. It's not possible for me to know the entire system. So my knowledge is limited. I can test only as per my knowledge. I can't. If I knew everything about the PayU system, there would not be any bug in the PayU system, because I know everything about it. The bugs are because of the unknown, which I don't know, right? So it's not possible to codify all the human beings observation, and we don't know the entire system. So it's not. So we can't spend efforts to, and plus there are a lot of changing components. So we don't need to spend effort in automating those changing components, because it won't actually help anything. We'll be just busy in doing automation, but actually the ROI of automation won't be there, because the effort we spend in automating a certain features which are actually going to change next week is actually go waste. Fine. So you know why to automate and what to automate, and when to automate. So are you all set to automate now? Maybe not. Let's see some more traps. So I would like to present here an example of a poorly written automation code. Now look at this example. In this example, this is the Java code for automating a web application. The web application which I've taken here as an example is a hotel booking web application, where a user can go to the home page, log in from the home page, search for hotels, select a particular hotel, make the payment, and can get the booking confirmation page. Okay, now this is a sample app which I've taken, and this is a before method which is written in Java. So this is a before method. It will run before the method, method, and then it says driver equal to new Firefox driver, means I'm launching the Firefox driver. I'm telling a URL, and then I'm saying, okay, wait for this URL. So what are the problems here? First of all, it has hard-coded browser. Now let's say I want to run the test case for another browser, let's say Safari or Chrome or Opera. I'll have to actually change the code over here. It's not configurable. The environment URL is hard-coded. Let's say I have multiple environments: staging environment, sandbox environment, PP environment, test environment, or blah blah, any other environment, and each of the environment has a different URL. For example, pp.something.com or test.something.com. I'll have to actually change the code to get those URLs. And what are these? Like the timeout. The timeout is hard-coded. For example, consider that somebody wants to run an automation on a staging environment, and the staging environment runs very, very slow, or some other PP environment which runs very slow. All your test cases will fail because you have hard-coded that the wait is only 30 seconds. It's not configurable. You can't increase the wait if your environment is working slow. Let's look at more examples. Now this is a test case. What happens in this test case? So this is in this test case, I'm going to the page. After going to the page, I'm entering the username and then entering the password and then clicking on the login button. So the problem here is that it has hard-coded object identifier. Imagine this thing: if the dev says I'm changing the username field XPath or CSS, and this XPath or object identifier is hard-coded in your test case, what will happen? And you have 1,000 or 5,000 test cases. You'll have to actually change each one of your test cases because you hard-coded the object identifier into your test case. And the next thing is hard-coded test data. So we are saying that, okay, enter the username as this thing. What if you want to run the same test case with some other test data? You'll have to change the things. And then you have hard-coded Selenium constructs. So what do you do? So let's say today's Selenium is popular. Tomorrow some other new technology comes up. For example, earlier QTP was popular, and tomorrow some XYZ new technology comes up. What will you do? Your test case has hard-coded Selenium construct. Let's look more. This whole business logic of login is hard-coded over here. So what if developer introduce or the product manager says we'll have a guest login flow? You like to actually change each and every test case, because the business logic of doing a login is hard-coded in each and every test case. The business logic should not be present in the test case. We'll look at those things next slides. Now let's look at the automation report. Imagine this thing: you have 5,000 test cases which are running every day, and out of those 5,000 test cases, 1,000 test cases fail every day, and you get a report like this. What will you do? Will you be able to debug those 1,000 failing test cases to find out, okay, why they are failing, just by looking at this error? You'll have to actually go and run each of the failing test case again to find out at what step the test case failed, because there is no sufficient logging, okay, that what happened before the step, at what step the test case failed, what were the steps which were executed before this error came. Nothing is logged over here. And then again, you'll have to manually repro. You can't just copy paste the logs and share with the developer, find this is the bug. You can't do that. You'll have to actually manually run each and every failing test case. So then, are you saving time or you are increasing burden on the team? And then there are no screenshot, no page HTML to share. Okay, fine. When the error occurred, how did the page look like? What was the page HTML? So this is what happens. In case of unplanned automation, you're actually creating a very messy situation for yourself. The automation, which was actually supposed to solve your problems, to speed up your testing, to make you more efficient, and actually, I would say to make you lazy, because automation will take care of testing. You can actually relax, will actually make your life messy. So obviously, you don't want to fall into those traps and make your automation a white elephant to maintain. So let's look into the things which you should do to get the max from your automation. So that's the theme of my presentation today. What are the key ingredients of a powerful test automation? So what I've done is I've divided my presentation into 10 tips which I want to share with you today. So there could be many more things which you can do to make your automation powerful, but I just picked up the 10 things which I loved most. So the tip number 1 is choose the right design. Again, I'll take the same web application of hotel booking web app, an example of a layered architecture. In a layered architecture, so now there are many design approaches possible. This is an example architecture which you can choose depending upon your application, your team strength. You can decide upon, okay, which framework, which library, Ruby, Java, C#, whatever library, whatever framework available in those languages you want to use it, but then again choose and plan a right design for your automation. Don't start unplanned automation. So for example, I'm taking an example of a layered architecture. This is one possibility of a design which you can do if you are automating something like a hotel booking web app. So in this architecture, I have 5 layers. The layer number 1, automation library layer, the framework core layer, the page object layer, the business logic helpers, and the test cases layer. Let's talk about each of these 5 layers, what these layers mean. So first of all, let's start with the page object layer. The page object layer, basically, what you do is you create pages for each and every For each and every page of your application, you create a class. So as in, let's say you have a home page in your application. So you create a home page class. And on the home page, let's say you can do a login. So you create a login method in that class. So the page name of the application corresponds to the class name. The UI elements present on the page, for example, the username, password, or login will be the UI elements of the page. And whatever actions you can perform on the page will become the method on the page, method of the class. And then it is mandatory to return the next page after a click. I'll shortly tell you, okay, why it is mandatory to return the next page after click. Now, once you've created the pages like this for each of the pages in your web application, the next you start joining those page objects to create business logic helpers. Essentially, what you do is, example, you have search hotel page, and the search hotel page, you know that, okay, you can do a login operation. So you say homepage.login. And when you do the login, you know that it returns you the next page. And then from the next page, you do perform search, which gives you the select hotel page. On the select hotel page, you click continue, it gives you the next page, which is booking hotel page. And when you click on booking hotel page, it gives you a next page, which is booking confirmation page. Now, as you're seeing here, as I'm moving ahead in the application flow, by doing operation on one page, I'm landing on another page. When I do some operation on the second page, I land on the third page. When I do some operation on the third page, I land on the fourth page. So essentially, I'm creating a linked list of various pages. I'm joining various pages together. That's why when I said in my previous slide that it's mandatory to return the next page, which will appear after doing that operation. So when you return the next page, you can actually write a business logic helper like this, where one page is returning upon doing an action, it is returning you the next page. When you perform some action on the next page, it gives you the next page. When you perform another action, it gives you the next page, and so on. And hence you create a linked list of various pages. So you combine page action like this to build a business logic. Now, once you have created the business logic helpers like that, now you can start working on creating your test cases. Now, how do you create your test cases? You simply use a business logic helpers. For example, what I've done here is I've used I created a helper.doBooking and then simply called that. Now, if you see here in my test case, there's an @test annotation where I'm actually writing the test case title. And then my test case is easy to interpret. It is simply like, and it matches with the manual test case. Even a manual tester can come and say, okay, fine. Oh, this test case is doing a booking using some login credentials, using some search criteria, using some booking detail, and it is verifying the booking success message. So this is a test case for doing a booking and verifying booking success message. The test case body is looking very neat and clean because you did not put any business logic or in the test case. All this business logic or the object identifiers, those are in the page object layer or in the business logic helper layer. The test case is actually very easy to maintain. So you use the business logic helpers a lot in writing your test case. The final two layers are the automation library and the framework core layer. So what you do here is the automation library layer is very simple layer. You basically import all the external libraries, jars, for example, Selenium, QTP, or any other third-party jar, for example, to read from the Excel or write to the Excel or any other external third-party jar you want to use for your automation, or let's say for image comparison or to PDF reader, something like that. Whatever library you want to incorporate, just incorporate that. And then you write a framework core layer. What is a framework core layer? It is a wrapper around various external libraries which you import. It offers you the uniform interface to the page object layer. So for example, I said today's Selenium is popular, tomorrow some other newer technology comes up. So with this framework core layer, you can actually abstract the Selenium from your page object or the test cases layer or the business logic helper layer. So what you do here is, let's say you write a browser class. Now browser class has all the methods to do various operation on the browser, or the element class has all the methods to do operation on an element on the page. For example, the element class will have click element, check element, uncheck element, enter data, click, submit, all sort of operation. And then behind the scene, it can use Selenium library or QTP library or whatsoever. Similarly, browser can have wait for page load, refresh the browser, navigate to a particular page, things like that, refresh a page. So all those action on browser, and you just have a interface in the framework core layer to interact with the automation libraries. So what this help is, you actually tend to abstract out the automation libraries. Additionally, you can do with logging also in your test case. So now your test case doesn't need to worry that, okay, when I'm entering some data or I'm clicking on some element, I also need to print in the test case that clicking on this element or entering this data into this text box. Because obviously, it's, as I told you earlier, that okay, you should have sufficient logs in your automation report. So unless you tell your automation test case that I'm clicking here, I'm entering this data, now I'm navigating to this page, when you get the automation report, how will you know that okay, what happened in the automation test case? By having a layer like this, you can actually do that logging or take care of some exceptional conditions in this framework core layer. So that was a quite big tip number one, that okay, choose the right design to reduce the maintenance cost. Basically something like that. What we saw here is that okay, you written your test case in a layered fashion, where if a developer says, oh, I'm changing the object identifier, you know, okay, you just need to change your page object of that particular page. You don't need to change any of your test case. So you reduce the maintenance cost heavily. Your business logic is at one place. Now, if a product manager says, I'm introducing a new flow, let's say a guest login flow, or I'm changing the way the current login functionality works, you just change the business logic. No need to change your test cases. Your test code becomes a lot more reusable. You have localized changes in your data and object repository. Your test cases are easy to understand, and it's easy to change underlying automation library. So these are the high-level benefits of choosing the right design. I hope things were clear so far. Now I have set of remaining 9 quick tips. This tip number 1 was quite big, but I have remaining 9 quick tips to share with you. Tip number 2 is keep your test cases configurable. What I mean by that is, don't hard code anything like this. For example, environment URL. No, you might want to run your test case on different environments, so don't hard code environment URLs. Make sure these things are coming from some external configuration file. The browser name, Chrome, Firefox, Safari, the platform, the object wait time, the database credentials, or basically any other parameter which drives execution. Don't hard code anything. Let it come from some external configuration file, and then control that using some Jenkins job. Make it parameterize in your Jenkins job, and then use the same automation without changing any code to run your automation using different configuration. So that's a tip number 2, make your automation configurable. Tip number 3 is make your automation data driven, so that you can run the same test case with different data combinations. For example, consider this particular code where I'm saying that, okay, fine, log in to the application, and the data to be used to log into the application is coming from some external Excel sheet, and I'm passing an Excel row number here in the method parameter, saying that login row number, and then using that row number, Excel row number, to then using those username and password to read from the Excel and doing login operation. So that way you will be able to run your same test case with different data combination without requiring any code change. Now tip number 4 is plan parallel execution. Now as the number of test cases will increase, it will take more and more time to get the automation report. Remember, the goal of automation is to offer you speed. You don't want that, okay, let's say today you have only 200 test cases, but somewhere down the line, let's say 1 or 2 years down the line, your test cases increase to 5,000 test cases. Now you don't want to wait for 24 hours to get the automation report. So start planning your automation, or start writing automation to make sure that they can run in parallel. One important criteria to make that for that is write non-interfering atomic test cases. What I mean by non-interfering is, when a particular test case is running, make sure that if you run some other test case in parallel, they don't interfere with each other. For example, if a test case, let's say, is changing some global configuration value, the other test case should not get affected. So isolate your test cases. They should not interfere with the execution of each other. It should not matter that what are the other test cases which are running in parallel to any given test case. You should be able to run any test case in parallel with other test cases. This is a very important design consideration when you are planning your automation. Otherwise, you'll be in a lot of trouble when the number of test cases increase and you want to run your test cases in parallel. What I have observed is, using a standard Windows 7 machine, you can run 12 parallel browsers and reduce your execution time to 1/12. So that's a huge saving, reducing your execution time to 1/12 actually on a single Windows 7 machine. What at PayU we did, we integrated the Jenkins master slave configuration with Selenium Grid. What happens over here is, so we have a Jenkins master machine and then the Jenkins slave machines. And then we have divided our automation into various feature areas. Each of the feature areas having, let's say, 100 to 200 test cases. Now we give those feature areas to Jenkins master machine to execute, and the master machine in turn tells one of the slave machine to execute those feature areas. But what happens if, as I told, okay, standard Windows 7 machine can run 12 parallel browsers in one go. What happens if, and in our case, for example, each feature area has more than 100 test cases. So while the 12 test cases are running in parallel, the other test cases are still waiting to execute. So what you can do is you can actually plug in the Selenium Grid with that, and then make your Jenkins master machine as a Selenium hub machine, as a Selenium Grid hub machine as well. And then this Selenium hub will actually distribute your pending test cases which are waiting for execution to the other grid nodes. And hence you can actually reduce the automation execution time and achieve horizontal scalability. In our case, we were able to reduce automation execution time from 14 hours to just 2 hours using this approach. So from 14 hours to 2 hours using this combination of Jenkins master slave with Selenium Grid. Tip number 5 is use or build rich reports. For example, a report like this, where you have the test case description, You get the complete logs when the test case failed, okay, that what all steps failed when the test case failure occurred, what happened before this test case failure. So actually you can copy paste this automation log report and file a bug. You don't have to manually repro the automation failure and then write the bug steps in the your issue tracking tool. Plus, you get the uniform logging of test case steps. So whatever actions were happened when that test case was executing, you get the uniform logging of that. Remember, this is coming from the framework code layer, which we talked about earlier. And then you get the failure page URL, okay, where the failure occurred. You get the screenshot of the failure and the page HTML when the failure, or the page how it looked like when the failure occurred. You can also use a plugin called LO reporting, which is a very good tool, fantastic tool. It offers you clubbing of the failures. So let's say you have thousands of test cases and hundreds of those test cases failed due to a particular reason. So you can use this LO reporting to club the failure reasons of those test cases. So for example, here it says, okay, the 10 test cases failed because of some gateway timeout. So now you can actually go to the developer, say that, okay, fine, 10 of my scenarios are failing because of this. So this is a high priority item. You can also implement various custom listeners to handle some unhandled exceptions which can occur in your test cases. So there are a lot of good methods which are offered by various testing frameworks, for example, TestNG or JUnit, whatever you are trying to use, something like on test failure, on test script, on test start, on test success, on finish, on start. So use those to catch all the unhandled exceptions from your test case, so that you can actually do the logging of, okay, fine, some exception has occurred in the test case. Otherwise, your test case will just fail without printing any logs, okay, why the test case failed, and then you will be clueless, okay, why this test case has failed. So you can log all those unhandled exceptions in your using these custom listeners. You can also do the cleanup task. Basically, any DB connection to be closed, you can close those DB connections using these custom listeners. And then you can do a lot of soft assert also using these custom listeners. Tip number 6 is customize your email results. Now, as I said, let's say you have 5,000 test cases. Don't send the report of those 5,000 test cases in one go to the entire team. Delegate the responsibility. Tell them, okay, fine, for these 100 to 200 or 500 test cases, this person is responsible. For these 100 200 test cases, this person is responsible. For these 100 200 test cases, this person is responsible. And split your whole automation suite into small chunks and assign those to various area owners. So as I say that, okay, define that, okay, fine, this is the area and this is the owner. I'll come to the accuracy part. This accuracy part shows that how accurate is your test case. As in a normal case, when the test case fails, example, consider you have 100 test cases and your 80 test cases pass and 20 test cases, what will you get in a normal test automation? You get 80% pass rate because 20 test cases failed and 80 test cases passed. Your pass rate is 80%. But what I'm talking about here is accuracy, not pass percentage. As a test lead or as a test manager, one of your responsibilities also to make sure, okay, that you make your automation reliable and solid. So you will obviously drive your team that telling them, okay, ask them, okay, why those 20 test cases failed. But then if those 20 test cases failed because of some bugs in your code, not your code, the developer's code, so then your automation tester can't do anything about those 20 failing test cases. They will just fail. They will have to just wait for the bugs to be fixed so that those 20 test cases pass. So in that case, I will term that, okay, fine. Even the pass rate is 80%. The accuracy of my test case is 100%. So that's the difference between accuracy and pass percentage, which I want to show in this slide. That, okay, number of test cases, find out that number of test cases which failed to the dev code issue versus number of test cases which failed to automation code issue. So in the same example, if let's say 10 test cases fail because of the dev code issue and 10 test cases fail because there was some issue in the automation test code, then your accuracy will be 90% because 10 test cases have failed because of the automation code issue. So test cases are not 100% accurate. Accuracy is 90%. So for your automation test cases, measure the automation accuracy. That's a tip number 7. Tip number 8, measure the code coverage. Measure that how many lines of code are you touching using your automation code. This gives you confidence about how deeper is your automation code. So various languages, for example, if your application is written in PHP, there are some good plugins available in PHP. If your application is written in Java, there are good plugins available in Java to measure that code coverage. So use those code coverage tools to find out what is the automation code coverage, and then use it as a measure to drive more coverage of your application under test and increase automation coverage. Tip number 9 is build continuous integration. What I mean by that is you have your test cases, let's say in some test case management tool, for example, test cases, and then you have your execution engine. So it has 3 pieces, broad pieces. One is a test case management tool, which is on the left hand side, and then you have the layered automation suite, which is on the right hand side, which we have already discussed, and the middle layer, which is the execution engine layer, which could be Jenkins or something like some build tool. So what you do there is that you fetch the Git code or from whatever source control, you fetch the code, compile that code, you get your test cases from the test link, and then run them using your automation suite, and then get the results and push the results back to the test link, and also publish the results over email. So all that happening automatically using some Jenkins job or so. So fetching the code, compiling the code, pulling the test case from the test link, executing the test case, and then getting the execution results and pushing the test case back to the test link. So that when your testers can actually see, okay, fine, these are the test cases which are present in my test case management tool and the automation line, and here I can see, okay, fine, these are the test cases which are passed, these are the test cases which are failed. So build a pipeline like that. Tip number 10 and the final tip of the day is do automated deployments. So we focus a lot on making our automation strong and building a continuous integration pipeline. But what about the deployment? When you get some code from the developer, automate that as soon as the developer gives you some code, the code gets deployed automatically, and then your automation is fired automatically and you get the automation report. So I would like to share one case study over here, which we did using in PayUMoney here, using Docker. So we use Docker to build production-like environments at PayUMoney. And then we have Jenkins job to deploy automation code, automatically run automation, and then share the reports. And all this happens in a seamless fashion. And this is a step towards the continuous deployments. So I have a small case study to present. So before we started doing this continuous deployment using this Docker, we were facing a lot of problems. A PayUMoney test environment consists of a Linux VM, about 15 Tomcat repositories, a lot of custom jars, Nginx, Apache, Redis master slave, RabbitMQ, MySQL master slave combination, and then lots of many other newer components were getting added as we were making the product stronger and stronger. Now the problem we are facing is that we had 40 testers in the team now and limited testing environment. So just to give an example, let's say I want to build a new testing environment. What I require is creating a new testing environment from scratch was an entirely manual process, taking somewhere around a week to a month of time to create a new testing environment from scratch, because you have to set up the machine, you have to configure the virtual machines, you have to configure all the softwares, all the libraries, then you have to configure all the repositories, all those 15 repositories with the proper configuration changes. You have to configure the DB, make sure that the DB is proper, that default data is present in a proper manner, then do the proper network configurations required for all those code, build the code, deploy the code, and it easily used to take 2 days to 2 weeks of effort to do all these things. And then we had a lot of shared environments. So 40 people in the team and 12 testing environments available. People were always sharing the environment with each other. So as an example, for example, 2-3 testers were using the same environment for their testing. And consider, and many times, a lot of time used to get wasted because, example, one tester was testing a change and a second tester comes and deploys his or her change on the same environment, and some, let's say, merge conflict occurs. Now both the testers are blocked because the code which was deployed is corrupted because a merge conflict has occurred. Now both the testers are blocked because they can't test. They'll have to just roll back. Or let's say a tester one was testing the change, and then the tester 2 comes and then takes the checkout of his code and removes the code of the tester 1, and now the tester 1 is saying the things are not working, while the true story is that somebody has come and removed the deployed code. Or let's say somebody wants to test a particular change, but then no testing environment is available because that particular change which a new tester wants to change is very breaking change. You can't test it along with other changes, and the testers are waiting because there is no testing environment available to test the change. So such sort of problems we were facing in PayUMoney before we used Docker. So the solution we employed was we used Docker, which offers you sharing of hardware and OS. Now we are able to create a fully functional environment in just 8 minutes. So remember, the effort of 2 weeks to 2 days to 2 weeks has been reduced to just 8 minutes. And for 40 people in the team, we have 40 test environment, and that to production like. So it offers you ease of configuration. So what happens here is that everything, environment creation steps are all at one place. All the scripts on the configuration changes are at one place. Now, if somebody wants to make a particular change, we don't have to send out an email to everyone in the team. Please update your environments for this configuration change. I have tested this change. This change is going live. Please change your environments, otherwise your environment will stop working as soon as you take the latest code. No, those problems don't happen now. You just make the configuration changes at one place, and then just push your deployment script into the repo, and then everybody gets those configuration changes in their environment. Ease of DB maintenance. So earlier, if somebody is used to run some wrong query, during the testing, course of testing, let's say the DB gets corrupted, that environment used to become unusable, and then again we'll have to go through the pain of creating the environment again. But now, if somebody corrupts the environment, we can always create a new environment again, just scrap the environment and create the environment again in just 8 minutes. So there are no shared services and all production like setup. Plus, this environment is very fast, they run very fast, and you can always rebuild in case of environment corruption. And we have observed 18 hours of saving per day by using this solution of automating our deployments. So that completes my 10 tips which I wanted to share with you today. I'm open for all the Q&A now.
Hi, Nitin.
Thank you.
Thank you, Nitin. Thank you so much for taking us through that very insightful presentation. And I would like to tell all our listeners that if you have any questions for Nitin, now is the time to type them in. Meanwhile, I already have a couple of questions with me that I have received, and I would like to go forward with a couple of them. So, Nitin, first up, when you were talking about the problems of unplanned automation, you had a very interesting slide. I think it was slide number 11, where you were talking
Okay.
about the it just very skillfully showed what could go wrong with unplanned automation. So I think one of the questions is, could you elaborate a little bit on that part? As in, you did show us two examples, but could you just go through a quick checklist of what are the things that can go wrong with unplanned automation?
Okay. Fine. So the things, basically we covered those things during the course of the presentation when I was showing you various examples of writing a poorly written automation code where, let's say, a developer is making, example, you written about 1,000 test cases and somebody comes in and makes a minor change. For example, a login page. Just stating the example, same example again. For example, you have a login page which is used by all your test cases, all your 1,000 test cases or 10,000 test cases, a simple login page. And then you have not planned to make your automation reusable. You've not planned the design of it. And that login page business logic is present on each and every of your test case. And the product manager comes and says, okay, now instead of login page, we'll just offer a guest login functionality also. And all our test cases, all our scenarios should work for that as well. But the login piece, the business logic is present in each of your test case. Now you can't, it's not possible to change all your 1,000, 10,000 test cases. For a developer, it's just a very small change. Just hide the username and password field and just comment out the backend business logic and just offer the guest login. So for developer, it's just half a day change. But for you, you have tons of test cases to fix now. But if your login functionality is also abstracted out in different layers, you can actually make a very small change in your automation test case and all your 1,000, 10,000 test cases will just work with a very small minimum change. So this is a very small example. Again, the tips which I shared, each you can actually think of the reverse of what if you have not done that. So for example, the tip number 2 was configurable. What if you've not written your test cases configurable? What if you have hard coded the things? So you'll obviously get to know, okay, the problems you'll face. I hope I've answered the question.
Yes, Nitin, I think you did a very good recap of that portion of your session. The next question I have here is that all the tips that you shared for building a powerful automation system, they no doubt make the whole process very streamlined. But if these tips are not followed, does it actually cost an organization more in terms of product development if the automation testing is not done right?
So you mean you're asking that does it cause problems?
Not just in terms of problem, does it also cost in monetary value? Does it cost more for the team if the automation is not done right?
Yeah. So you obviously, so what will happen is that your automation team, all the senior managers and the, let's say, CEOs of the company, okay, if they look at this automation team, people will say, oh, this is the most busy team. in terms of, okay, they're always at work, they're so busy. But the truth reality is that yes, they're busy, but they're actually producing zero ROI because they've not followed the proper design practices of doing automation, and hence they've actually shot themselves on their own feet by not doing the automation in the right manner, and hence they're paying a price because the application is evolving. Now, as the application is evolving, their automation is breaking every day. Now, since their automation is breaking every day, they are very busy in fixing it. They're very busy in coming to at par with the newer application changes rather than helping the product by finding bugs through their automation. So they should be actually writing automation which is very stable, very reliable, which is able to catch bugs before they go live, and then offer the manual tester a speed to execute, to, to make sure, okay, that to get a confidence that they can send any code change live in the without breaking any legacy stuff. So if the automation is not planned properly, the ROI will not be there, and the team will actually suffer. Even and your automation tester will will look very busy, but they will be busy but not producing any worth effort.
Definitely. So I think that portion has become very, very clear now why it's important to follow all these 10 tips. There's another question that has just come in, which is, and I think you dealt with it extensively in the first portion of your presentation, but still the question that comes up is that should we remove manual teams if we have automation? Or how much can we scale down?
No, not at all. You see, I can't answer the how much part of it,
Hmm.
but obviously you can't replace the human mind. I'm again saying that, okay, researchers, the scientists, people are still trying to work on the autonomous cars, the robots and all. People are still trying to build, but nobody has been successful in building something smart as human brain. So human being can always notice thousands of things at the same time, but you will have to actually train the machine learning and all, or machine will you know train. And I don't think we are writing the automation to the grade of a machine learning algorithm that, okay, it will learn that, okay, this is also a bug without us coding. And not because I've not seen automation code which also tells those bugs which are not coded for. Whatever automation I've seen so far is it will tell only those assertion, only those failures which I've told automation test case to tell me, okay, fine. If you see this, then the test case pass. If you see this, then the test case fail. But I'm not seeing that, okay, automation test case fail. That, oh, I also notice one more thing, and hence automation is pass or fail. That machine learning kind of automation is not seen. Only a human being can notice those extra things. So you can't replace a manual effort.
Uh,
You always need to draw boundaries.
okay. Uh,
Yeah,
sure. Sorry. Go ahead.
yeah. So I'm done.
Okay. So, you said we cannot replace the manual team, but with your experience at PayU till date, is it possible to maybe get to a point where you know this bits are to be automated, and these are certain tasks which are certain QA tasks which are definitely should not be automated? Like this has to be manual.
Yes, yes, yes. So there are tasks which are clearly defined, very straightforward. The things have to happen only in this way, only in this way, which I know. And I know these are repeatable, which will always happen in this fashion. I always automate them. Wherever I see a need, okay, that somebody needs to actually see and tell, okay, whether this looks okay or not, I'll keep it manual. So for example, there is a page, a visual appeal of that page. A UI designer has designed the page. It's not possible to automate the UI, how the page will look like, okay, because that's more of a UI kind of thing, okay, whether it looks appealing with the current shape or not. But then the basic functionality, okay, fine, the for example login part, when I log in, a welcome message is appearing or not. Now these this is very straightforward. It should appear fine. This is I'm automating that. But then the visual look and feel of the page, that I'll leave it to the manual tester to conform to it.
Okay.
This is just a very simple example.
Sure. Thank you so much. So I think with that we've come almost to the end of the session today. If our listeners still have any questions, I think you can send them to us mail them to us at webinars@srijan.net, and we will take them up with Nitin and get them answered. Or you could reach out to Nitin directly on Twitter. I'm sure you have his Twitter handle by now. I think, Nitin, with that, I would like to thank you for joining us here today and taking us through that very insightful presentation. And I'm sure all the QA devs who have attended the session or who will come across your presentation will be sure to, implement these 10 tips whenever they are working on a QA automation test. You've been a wonderful host, Nitin, and I think I would like to thank the audience as well for joining us today. And with that, we have come to the end of the webinar. Thank you all for joining us today. Thank you so much.
Thank you very much.